Hello students. Today we are going to see the fourth module wherein you will be having the dynamic programming. Okay, so when you talk about this dynamic programming, what we are going to see here is um, it's like a process which is invented in 1950 by. So when you say it as the dynamic programming, mm, here it will be generally it will be consisting of it's a method for optimizing your multi-stage decision process. Okay, where you can say that it is a planning concept with overlapping sub-problems. So what we do here is today we will be moving on to the planning concept where we can say that how you can create a recurrence relation and solve this problem. So you will be having various sub problems. Okay, so the sub problems can be solved. So when you solve it, you are going to solve the problems more than once. But where in dynamic programming what we are seeing is whatever problems sub problems we are solving it, we will be solving the sub problems only once and it will be recorded in the table. So it for avoiding the usage of the extra space also we can use the dynamic programming method, where you will be having two methods. One is your bottom up approach and another one is your top down approach. Bottom up approach, all the sub problems will be solved. A top down approach, only certain problems sub problems will be solved. Whatever it's wanted, that will be necessary, that will be solved. So unwanted things will not be solved, and it is also called a memory function. Why? Because we can utilize this memory functions in a better manner. So here, when you go for the dynamic programming, what we are going to see here is the dynamic programming will be taken for any kind of problems, where we will be just seeing how to create a Fibonacci sequence. You would have all know about the Fibonacci sequence. The Fibonacci sequence is nothing but you will be having some values. Okay, it is a sequence which will be consisting of a set of numbers which will be adding the consecutive numbers. So if you write an algorithm, you can see if n equal to 0, you will be returning with 0. Else what you will do, you will be interchanging you will be adding the values and interchanging the values, and you will be repeating it for n times. So you initialize first the two values 0 and 1. 0, 1 is been initialized. To get the next number, just add 1 plus 1, you will get 2. 1 plus 2, you will get 3. 3 plus 5, you will be getting 8. 8 plus 13, you will be getting it as 21. So this sequence will be going as a for loop, where you will be saying that x1 is 1 and x2 is 2. 1 plus 2 you will be adding, and you will be getting a new value for as x3. So this will be interchanged again and again till you find the sequence. So here you have a top-down approach which requires the order of n space, and the running time will be given in base of omega of n squared. So here you can write a recursive algorithm also for the Fibonacci series, where you will be checking for the null value and it will be repeatedly being used for all the integers. Only one thing you need to keep it in mind is you need to initialize the values. So here we are taken the initialized values of 0 and 1. So here you can see when you go for the Fibonacci sequence, you will be calling the Fibonacci sequence, where you will be checking for the null value, and the two previous values are added, you will be returned with the current value. So this recursive process is a bottom-up approach, where you will be just using the memory functions. Whenever you need certain values, we will be utilizing it, those values with the known factor. So here you can see whenever you go with the Fibonacci sequence, we are going to get a sequence of values with all the values, and you will be generating it. So here you are given a tree structure where you are mentioning about the index as well as the values. So each value is being repeatedly used, so that will be that we will be storing it. For example, suppose if you see that if in this whatever value, initial value we are taking it, then all the values will be stored in the form of a table. So those table values will be retrieved and it will be later used for the purpose. So whatever values we have now, if you want to use get the next value, you just use the whatever is there in the previous value. That is, this is nothing but it is called as the Fibonacci sequence, where you will be using the top-down approach or the bottom-up approach for the dynamic programming. So here in our dynamic programming, we are going to see with the next problem, which says that it's going to compute a binomial coefficient. So here it is used for applying it in the non-optimization problem. So when you say it as the binomial coefficient, okay, it is denoted of C of n comma k, which is the number of combinations k elements from an n element set. So where your k will be varying from 0 to n. So you would have seen in your school days how to find out the value of NCR. How will you find out NCR? NCR is nothing but it is found out by saying it as NCR is nothing but it is equal to n factorial. You will be saying it as n factorial divided by r factorial into n minus r factorial. So this is how you find out the value of the NCR. So here we are going to use the binomial formula, where in the binomial formula this will be replaced with the help of formula which says that for to get a plus b to the whole power n, we are finding we are using the formula of C of n comma 0 into a power n plus into b power 0. B power 0, you know, it is equal to 1. So plus next C of n comma 1 into a power n into b power 1 plus etc. up to, if you see the ith term, it will be C of n comma I into a power n minus I into b power I, plus the last term will be C of n comma n into b power n into a power 0. A power 0 is 1, that is. So a power n minus 1, a power n minus 2, etc. it is reduced to a power 0. B power 0, b power 1, b power 2, etc. it is increased to b power n. N comma 0, n comma 1, n comma 2, etc. it goes up to n comma n. So the general formula for this is C of n comma k is nothing but C of n minus 1 comma k minus 1 plus C of n minus 1 comma k, for k lies between 0 to n. And your initial value C of, it's a recurrence relation. Always you should keep it in mind that whenever you go for a recurrence relation, you need to have a initial value. So here we are having the initial value. So the overlapping of subproblems is nothing but whatever values it is needing for our calculation, it will be stored in the form of a table. The values are taken it from the table for further utilization. So here you are saving the time as well as the memory is also be saved. So when you go for computing a binomial coefficient, you are creating a table. This is the form of a binomial coefficient, where you will be going for the number of rows. If you see, it will be from 0 to n. There will be n plus 1 rows, including 0th value. Similarly, the column will be, we are going to find out the value of C of n comma k. So you will be starting from 0, it will be going on till k. So your C of n comma k will be depending upon the previous terms. So always you need to complete the previous rows to calculate any of the values. So here you can see that your value C of n minus 1, C of n comma k is depending upon C of n minus 1 comma k minus 1 and C of n minus 1 comma k. If you add these two, here you can see, if you add these two, you will be getting the value of C of n comma k. So whatever values we are storing it, maybe it will be used later. So we will be, instead of recalculating it again and again, we will be storing it in the form of a table. So if you see the first column, if you see all values are 1. Similarly, n comma n is 1. So 0 comma 0, 1 comma 1, 2 comma 2, everything should be 1. So now we can see the calculation of 3. The value of 3, again 3 comma 0, if you see, it is 1 itself. There is no change. Now, what will be the value of 3 comma 1? When you say it as 3 comma 1, you are supposed to find out 3 comma 1 as C of n minus 1 comma k minus 1. So n minus 1 is nothing but it is 2 comma k minus 1 is 0. So what is 2 comma 0? 2 comma 0 is 1 plus C of n minus 1 comma k. What is C of n minus 1? C of n minus 1 is 2 comma k. K is 1. 2 comma 1 is also, it's already calculated, it is 2. So it will be equal to, here the value will be equal to 3. Same thing, you need to calculate for 3 comma 2 also. Now when you say it as 3 comma 2, what will be the value? It will be depending upon C of 2 comma 1 plus, it will be also depending upon C of 2 comma 2. What is 2 comma 1? 2 comma 1 is, you are getting it as 2. What is 2 comma 2? 2 comma 1? 2 is 1. So again 2 plus 1 is, it is nothing but it is. Similarly, you need to also find out 3 comma 3. So when you find out 3 comma 3, you are just using the initial value. What is n comma n? N comma n is 1. So here you will be filling it as 1. Next we may have to go for 4. Okay. So here you will be finding for any given values, you need to calculate and find out what is the value for the table. So whatever you are finding it, you will be using it for computing the binomial coefficient. So here you have an algorithm based on the formula which says that for I equal to 0 to n, what you are doing, you have an inner loop which will be going for. Now always remember that if at all you want to calculate the value of any values, always your n should be greater than k. Suppose if I want to know the value of 4, I will not be taking the value as 4 comma 6. You can take the value of C of n comma k as, you will be saying it as 6 comma 4. 6 comma 4 means you will be calculating for 4, you will calculate for 5, you will also calculate for 6, and you will be here, you will be going only up to here, you will be going up to a maximum of 4. Here you will be going 4 comma 4, you will go for 5 comma 4, then you will be starting for solving for 6 comma 4 and get to know what is the binomial coefficient. So here the binomial coefficient is nothing but it will be storing the values, it will be stored in a table, and from the table we need to take the values. Okay, it's clear? So now based on this, for this algorithm, if you see, we will be working out this algorithm saying that your initial value is j equal to 0 or j equal to I, it will be c of I comma j is 1. Else what you will be do, you are saying that c of I comma j is 1. Else c of I comma j is, it is based on the previous value, c of I minus 1 comma j minus 1 plus c of I minus 1 comma j, and you will be returning with n comma k. So here when you see the time complexity, the time complexity will be calculated and based on two things. What are the two things? We will be, for this table, if you see, it will be in the form of, if you say that we are going to calculate a 6 comma 4, it will be in the form of a, up to this, it may be a rectangle, and beyond this it will be in the form of a triangle. Okay, so this is what we are going to find out in this binomial coefficient. So in binomial coefficient, this is the algorithm given, and we need to find out the time complexity. So always you remember that since it's a recurrence equation, it will be solving all the values and it will be finding the solution for it. So now when you say it does the time efficiency, the time efficiency also for all the k plus 1 rows, first k plus 1 rows of the table, it will be forming a triangle. While the remaining n minus k rows, if you see, it will be in the form of a rectangle. So we have to split the sum expressing a of n comma k as two parts. What are the two parts? It is in the form of first k plus 1 rows is in the form of a triangle. So you will be saying it as I equal to 1 to k, equal to 1 to j equal to 1 to I minus 1. What is the value? And similarly for n. So from that you will be reducing it. So this we will see it in detail. So here you have the time efficiency. Time efficiency, if you see, here it's given. So I equal to 1 to k, j equal to 1 to I minus 1, 1. So if you know, if you see that it is 1, then it's obviously you can use the upper bound, lower bound formula. So that is nothing but upper bound, lower bound formula is nothing but, we will be saying it as what is upper bound? Upper bound is I minus 1, minus 1 plus 1, minus 1 plus 1, it will get truncated, so it will get I minus 1 plus summation. Again, here also it is upper bound, lower bound formula, because it's 1. So you will be saying it as k minus 1 plus 1, which is equal to k. So now here you use the summation formula. Summation I equal to 1 to k is I minus 1. So what is the last term? It is k. So into k minus 1 divided by 2 plus k into n minus k. So you just evaluate it. K into k is nothing but it is k squared minus k divided by 2 plus k into n minus k squared you will be getting. So when you equate this equation, you will be getting it as when you evaluate everything, you will be getting it as this divided by 2. So approximately equal to n into k. So we will be saying it as it is belonging to nk. Okay. So this is how we will be evaluating it and finding what is the time efficiency for the binomial coefficient. So in binomial coefficient, we have to see how the problem is being given. So here, if you see the problem, you will be getting to know that it is based on a recurrence relation. We are solving it, and you will be having smaller subproblems of the same type. So if at all you have any overlapping subproblem, it suggests that each of the subproblem will be solved once and it will be recorded in the table. So that we can, it is applicable for the Fibonacci sequence also. Fibonacci sequence also you have seen whatever values you need. For example, if you need the value of to calculate f of 10, if it is needed with f of 9 and f of 8, f of 9 and f of 8 would have been already calculated and we will be storing it in a table that will be further used. So here you can avoid the usage of extra space, and you have to both the approaches, top down as well as bottom up approaches. Top down and bottom up approaches will show how you will be able to do it with them. So whenever you go for any problems, generally we use it as a recurrence relation. When you say it as recurrence relation, obviously you know that there is an initial condition. So with the using the initial condition, we will be solving the problems and record all the values in the table. So whatever table value whatever table value you are having it, you will be recording it and you will be utilizing it for any problem. So this is how you need to find out the dynamic programming method. It is a very efficient method where it has been used for the planning concept, where it is used for solving all the subproblems. Whenever there is a overlapping of subproblems, it's there. Immediately you use this technique and you will be using the dynamic programming method. So in dynamic programming itself, we have various problems like Floyd's partial program is there, knapsack problem is there. All these can be solved by using the dynamic programming, wherein you will be seeing that it is so always remember that whenever there is a problem given, to find out each stages, you just record each and every stage in the table. So whenever the table value is triggered, we will be just retrieving the value from the table and we will be calculating the finding out the solution. So this is how it is being efficiently used, the dynamic programming. We have seen only the brute force technique, divide and conquer technique, decrease and conquer technique, etc. But a dynamic programming technique is also a very good concept which involves the calculation of the values and how to retrieve the value whenever it is essential and how will you be storing it in a table. So this table indicates that all the values evaluated will be in the form of the solution where you will be having a original problem. And next step we will after this binomial coefficient, we will be moving on to the Warshall and Freud's algorithm, where again it is also having a recurrence relation, where in each and every recurrence relation, if you see, we will be it is used for finding the final value. So the transitive closure or the adjacency matrix or the shortest path, whatever you name it, that will be obtained by using the Warshall as well as the Freud's algorithm, where it will be generating all the states, all the nodes values will be erased and you will be storing it with the new values. So whenever you feel that you are familiar with that particular process, you can retrieve it from the table and get to know what is the value for each and every process. So that's all about the dynamic programming introduction, where mainly it is concentrating on how to solve the overlapping subproblems. And once the subproblems are solved, how you can easily identify what is the value. So that's all about the introduction chapter. Next we will see the Floyd's and versions are further in the next class.